This is Pre-Calc 5.3. We're going to be using the sum and difference identities on the first side of your notes to prove further identities. And in these two examples, we're going to start with the less complicated side and make it look like the more complicated side. So I'm going to start here with the sign of 3x, and I'm going to think about the sign of 3x in terms of a sum. Easiest thing for that would be 2x plus x. So using my sum identity there, I know that that is going to be the sine of 2x times the cosine of x plus the cosine of 2x times the sine of x. Now what I don't like about that right now is that I've got a sine of 2x and I also have a cosine of 2x, and I don't see that anywhere in where I'm supposed to be headed. So I'm going to take those two pieces that are underlined and I'm going to break them down even further. So I'm going to think about here the sine of 2x. Well, if I break that down into the sine of x plus x and use my sum identity, then I'm going to have the sine of x times the cosine of x plus the cosine of x times the sine of x. And that's pretty cool because I'm noticing here that those are exactly the same things multiplied together. So really I just have two sine x, cosine x's. So where I see the sine of 2x, I'm instead going to put 2 sine x cosine x. That's right up here in red. And I will put that in just a minute. Now let's look at the cosine of 2x. I don't like that either. I'm going to work with that. So this cosine of 2x, I'm going to think of that more like the cosine of x plus x. And using that pattern, that identity, I'm going to have the cosine of x times the cosine of x minus the sine of x times the sine of x. And again, something kind of neat happens. I have cosine times cosine, which is cosine squared of x minus the sine squared of x. So where I see cosine of 2x underlined up there, I can replace it with this. So let's go down here a little bit, extend the page, and adjust. Now, I'm going to take my original line that you see at the very top of your screen, and I'm going to replace what's in red with what we have in red, and what we have in blue with what's in blue. So then, basically, we'll have the sine of 2x plus x is really equal to 2 sine x cosine x. And then we've got that cosine x left from up above, plus, now the stuff in blue, I've got cosine squared x minus sine squared x. And I'm using parentheses because it involves subtraction, and it's a quantity. And there's my sine x from above. So I just took this and I replaced red with red, blue with blue. And now we can clean it up a little bit. So right here I see I've got a cosine times a cosine. So that's 2 cosine squared x sine of x. And on the right hand part here I'm going to have to distribute. So I have cosine squared x times sine of x. And I've got a sine squared times the sine, so that's minus sine cubed of x. And I'm also seeing that I've got this term and this term are exactly alike, just different coefficients. So if I have 2 here and 1 there, I have a grand total of 3. So that's 3 cosine squared of x sine of x. That's minus sine cubed of x, and that is exactly where we were supposed to be headed. So there is the sine example. And we also have a tangent example to look at. Here's the tangent example. Now the key to this one is looking at what you're taking the tangent of. We have 5x and 3x on the left side. On the right-hand side, we have 4x's and 1x. So there's a link there between 5 and 3, 4 and 1. And here's what we should be thinking about. 5x is just 4x plus 1x, whereas 3x is 4x minus 1x. So you see they're using the same two angle measures, but one as a sum and one as a difference. So I'm going to look at each of these pieces individually and rewrite them using the identities, splitting them up the way that I had written in the top corner. So the tangent of 5x, using the tangent sum identity, is the tangent of 4x plus the tangent of x over 1 minus the tangent of 4x times the tangent of x. And you will probably be needing to look back at those and use them. These will be given to you on a formula sheet. The tangent of 3x, same pattern, but we're doing a difference this time, so the signs will be a little different. So we have the tangent of 4x minus the tangent of x over 1 plus the tangent of 4x times the tangent of x. You may want to pause there just to make sure you've got all of that. Okay, so now I am going to be multiplying these two fractions together. So that means I am taking numerator times numerator, and I'm going to take denominator times denominator. I'm going to skip a few little steps here and talk to you about what's happening with these guys. If you notice that they're exactly the same on the top, the numerators are exactly the same, except one has a plus, one has a minus, and we call those conjugates. Now when you multiply conjugates together, your middle terms, as we call them, drop out. They will be exact opposites. So in this case, your tangent x, tangent 4x would multiply together, and then you'd have a negative tan x, tan 4x. So they will cancel. So what's going to happen is we take tangent x times tangent 4x, tangent of 4x times itself, and we're going to have tangent squared of 4x, that comes from this times this. And then the middle terms will cancel out like we just spoke about, and the next term, when we take this times this, will be minus tangent of x, tangent squared of x. Similar thing is going to happen on the bottom. They are also conjugates of each other. So the 1 times 1 will give us the 1. Our middle terms will cancel out when we multiply those together. And then we have a negative product for the last piece, and that is tangent squared 4x times tangent squared of x. And that is exactly where we were supposed to head. That is all.